Hey, welcome to this short topic called equations involving indices. So, we dealt with indices when we were studying number systems, and we learned quite a handful of rules or laws on indices. This was supposed to be part of that topic, but I couldn't teach that because I didn't expect you to have the skills of dealing with equations by then. But now that we have studied equations, so I now know that you are well equipped at handling equations involving indices. So the basic knowledge or skill that you need to have is this. So 4 can be written as 2 to the power 2. 2 to the power 2 is 4. So another way of writing 4 is writing it as 2 to the power 2. 9 is 3 to the power 2. 27 is 3 to the power 3. So the basic principle, the main principle that is used in solving equations involving indices is is two indices are equal if one their bases are equal. So if you have been given two indices and those two indices are being said to be equal, then their bases should be equal. And two, their powers are equal. Their powers should be equal. For example, if you have such a situation, this is an index because it has power. And anyway, this is also an index, and number is an index because they have got an invisible one. So these two are equal only if the bases are the same. What does it mean to have the same bases? This is the base 2 and 4 is the base. They should be the same numbers. And the powers should be the same. This is x and the power here should be the same for these two indices to be equal. So how do we make them equal? What we do is we manipulate a side that usually doesn't have a variable. So we have to manipulate one of the numbers so that we write it in the form such that the bases are equal or the powers are equal. So 4, we can manipulate it. How? So 4 can be manipulated. How we can do that is simple. 4 can be written as 2 to the power 2 as we have seen here. So writing 4 as 2 to the power 2 might look like this. So 4 has been replaced with 2 to the power 2. So 2 power x and 2 to the power 2, the bases are now the same, meaning that the powers should also be the same. So that's how to manipulate indices. So how do you get the answer from here? The bases are the same. Sorry, I was just disturbed by a phone call. Yeah, so how do we get the answer from here? So the bases are the same. The indices should also be the same. Therefore, you can just write, since 2 is equal to 2, so you can just write x is equal to 2. It means you have solved the question. So let's try this one. X power 2 is equal to 9. X power 2 is equal to 9. How do we solve this one? So 9 can be manipulated so that the powers are the same. Of course, we have got a base which is a letter. So this one, it's the one we're solving for. So of course, there's another way in which you can deal with this. You can just introduce the square root and this side the square root. Remember how we were dealing with equations of such nature when we were studying subject to the formula. So you can just introduce the square root here and the square root here. It means you have solved. But another way in which you can deal with this is you just write this in the form such that the powers should be the same with this one, which we don't know. And 9 can be written as 3 to the power 2. So the powers are the same, meaning that the bases should also be the same. Therefore, this number here should be 3. So we can write as x is equal to 3. Another one is this one, x power 3 is equal to 81. Again, this one can be easily solved by introducing cube root and this side cube root. So if you introduce cube root here and this side cube root, you're going to have the cube root is going to cancel with the power 3, and the cube root of 81 is going to give you 3. But another way in which you can solve this is by writing 81 such that it has a power of 3. By that I mean writing it like this, 3 to the power 3, which is 81. So the powers are the same, 3 and 3 are the same, which means the bases should be the same. X and 3 should be the same, meaning that x. What about this one, 3x to the power 27? So again, this one can be difficult to solve using the normal way of subject of the formula, but 27 can be written in the form such that the base is 3, because we know that the base is 3. So even this side, the base can be written, 27 can be written so that its base is 3, like this. So 3 power 3 is 27. The bases are the same, mean that the indices must be the same, the powers must be the same. X is equal to 3. What about this one? 5x to the power equals 125. 5x equals 125. Again, 5x, 125 can be written so that the base is 5, like this, 5 power 3. So the bases are the same, mean that the powers must be the same. So x is also equal. What about this one? Half power x 1 over 4. Half power x 1 over 4. How can we deal with this? So this one has to be written so that the base is 1 over 2. How can it be written like that? Simple. We know that we can look at the denominators. This is 2, this is 4. So 4 can be written to have a base of 2 by writing it as 2 to the power 2, and 1 and 1 are the same, which means we can write this as this. Half power x is just the same 1 over 2 power 2. Remember the distribution law of indices. It means these 2 can be the power of this one, and these 2 can be the power of this one. But 1 power 2 is just 1, and 2 power 2 it's 4. Mean that this and this are one and the same thing. 1 over 4 is just the same as 1 over 2 in brackets power 2. With this in mind, we can see that the bases are the same. The bases of this one is half, and the base of this one is half, and the powers should be the same, mean that x is equal to 2. What about this one? 4x power 8. So follow me here. So here we need to write this so that the base is 4, but there is no in which you can write 8 to have the base of 4, because 4 power 2 is going to give us 64. I mean 16. So there's no in which 8 can be written to have a base of 2, to have a base of 4. So what we can ask ourselves is, can this 4 be written such that it has a base which we can also write 8 to have the same base? 4 can be written to have a base of 2, and 8 can be written to have a base of 2. So this is the skill. If you cannot find, you cannot write this number such that it has a base of 2, what you do is you ask yourself, can I change this part to have a base of sorry, let me say that again. If you cannot write this to have this base, then what you can do is you can look for another base in which both of these numbers can be written. So 4 can be written as 2 to the power 2, and 8 can be written as 2 to the power 3, meaning that the bases are the same. Therefore 4 can be written as 2 to the power 2 in brackets, because we've got another power x outside, and 8 can be written to have a base of 2 power 3. Then we can use the distribution law, where we multiply x with 2 so that we remove the brackets. So we're going to have this 2 times x going to be 2x and 3. So this implies that the bases are the same and the power should be the same, meaning that 2x should be equal to 3. So we're going to have this 2x is equal to 3. From here now, we can solve for x by dividing both sides by 2. When you do that, we're going to end up with 3 over 2 as the answer. So this one we have discussed already. So let's take a look at one exam type of question. So let's see. Find the value of n if 4 power n is equal to 2 power 2 times 4 power 2. So that's how complicated they might appear in an exam, but the principles are the same. So find the value of n if 4 power n is equal to 2 power 2 times 4 to the power 2. So how can we deal with this? So there are many ways in which we can go about it, but the job is to make sure that since the index is the one that that we're looking for, the power is the one that we're looking for, so we can write the bases such that they have the same expression, or they have the same base. So here we have 4 power n, here we have 2 power 2 times 4 to the power 2. This part looks complicated, so we can try to simplify it. So 2 power 2 times 4 power 2, is there a way in which we can simplify it? Yes, there is. Maybe we can write 2 to the power 2 as 4. We can evaluate it. So here's the solution. So the first step is sorry, I'm being disturbed by phone because I'm having a very busy day today. Yeah, so let me just continue from where I was. So this is 4 power 9, this 4 power n, then this side we have 2 power 2 times 4 power 2. So 2 to the power 2, sorry sorry, so we write all the bases to have the same base. We write all the bases to have the same base. So I was explaining something of writing this to be to have evaluating this like 2 power 2, writing it as 4. That is another way. Another way in which we can go about this is we can write all these with a base of 2. So 4 can be written as 2 to the power 2. This 2 to the power 2 can maintain, and 4, this 4 can also be written as 2 to the power 2. The other powers are going to be outside the brackets, of course. Then we can expand the powers using distribution laws, which means 2 is going to be multiplied by n, and this 2 is going to be multiplied by 2. So we're going to have this 2 times n is 2n. This 2 just maintains. 2 times 2 is 4. From here, we can use the multiplication law, where we say if the bases are the same, then we can add the powers. So we're going to have 2 to the power 2n this side, and this side we're going to have 2 plus 4, which is equal to 6. So we're going to have this. After this, the bases are the same. So 2 power n can be equated to 6, like so. And we can divide both sides by 2, and we're going to get n is equal to 3. So this is another way. Another way to deal with this, we could have written this 2 power 2 as 4. So once we have 4 here, we know that 4 is to the power 1. Then we can use the multiplication law by combining 4 to the power 1 times 4 to the power 2 as 4, 1 plus 2 on top. That is the powers are going to add. So we're going to have 4 power 3. Then here we have 4 power n, and the whole of this side of 4 power 3. So the bases are the same. Then the powers n, and the power this side is going to be 3. So n is equal to 3. So that's another way in which you can deal with it. But the job is to make sure that you have the same bases. So this is how to deal with exam types of questions. Otherwise, this marks the end of this small short topic. I hope you have enjoyed and hope you get all the skills from here. Happy solving.